Assalamualaikum warahmatullahi ta'ala wabarakatuh and have a very good day. Today I'm going to share with you how to design reinforced concrete Palcap design. So here is the introduction on the Palcap design. So as a student, at the end of this lesson, you should be able to understand the function of Palcap, estimate suitable Palcap dimension including numbers of pal, design the main reinforcement, tension or bending reinforcement in Palcap and carry out shear check of the Palcap using beam theory and also truss theory. And the last one is draw the Palcap details. There is a few types of foundation. Types of foundation that can be applied to a structure, which is what we have done before, which is the pad footing, and then combined footing, strap footing, strip footing, rough footing, and the last one is a pile foundation. All those five examples at the above is considered as a shallow foundation, while the pile foundation is considered as a deep foundation. Therefore, the selection of the foundation type for a structure is depend on the first is type of the structure and the loading. What types of structure, for example, either it is a single story house, double story house, a multi-story house, tower, sewerage treatment plant, infrastructure, dam, and so on. Because based on this type of structure, they will determine what is the suitable loading that is being calculated or considered in the structure that will drive the suitability of the foundation. Second one is the soil properties and also condition of the site. For example, from the soil investigation, we will know what is the type and the strength of the soil in order for us to choose the suitable foundation types. For example, if it is a soft soil, there is a possibility types of foundation that we're going to use is a deep foundation. Although we can use a shallow foundation that have an homogeneous settlement, for example, is rough foundation. For example, if we have a very strength or strong, very high strength or strong soil condition, we can use a pad footing or strap footing or strip footing as a foundation. The third one is the permissible amount of the differential settlement. Because if we have in a non-homogeneous settlement of the structure, there is a of the soil, there is possibility crack or failure of the structure during we apply a load or after we use the building. Furthermore, there is a possibility failure of the foundation, such as overturning moment due to the overturning moment because of differential settlement of the structure. So it is important for us to choose the right types of foundation in order for us to make sure that the soil can receive all the superstructure loading. Then in the PAL foundation, okay, in this subject uh, we only studied on how to determine or the suitability of PAL being used as a foundation, but we didn't do a design on the PAL. Either it is because in a PAL foundation design, there is a few more advanced study that we have to do in order for us to design a PAL, because we have a few types of PAL. For example, we have a board PAL, we have a bearing friction PAL, and bearing PAL. So in this subject, because this is a reinforced concrete subject, we only learn how to design the Palcap. The Palcap is actually the element, okay, that is used to support, okay, the superstructure and also the pile foundation. It is a connection between the superstructure and also the pile foundation. Okay, pile foundation is selected to support and transmit load from the pier and column. Okay, means that the soil stratum with sufficient bearing capacity to support the loading is located too far away from the ground level to the deep, where for economic use due to height cost excavation. Because if we have a very low strength of the soil, it is not possible for us to excavate and fill up with a new soil to increase the soil capacity or soil bearing capacity. Therefore, the solution is we using a pile foundation. We penetrate the pile either using a jacking system or injection system or hammer system until it set to the end bearing. Okay, so a stiff and rigid medium is required to connect a group of pile so that the load from the support column is able to transport it safely and evenly into the pile. This element to transport the load from the supported column to the pile is called as a pile cap. This is the element that we are going to learn how to design by using two different methods, which is the beam theory and also truss theory. Durability requirement. In reinforced concrete, durability is really important because we are this in reinforced concrete there is a combination of two different material, which is concrete and steel. We know that concrete is very durable, where steel is less durable because it is easily affected by the surrounding environment due to the corrosion and due to the any impurities, because it is easily to get corroded. Okay, therefore thing is the concrete for the pile cap is subjected to more severe exposure condition. If it is located at the worst condition, for example, if it is nearby the coastal area, it is exposed to the seawater, is exposed to salt and carbonation problems. Okay, because it will penetrate into the soil and it will affect the structure. If it is, for example, at the dumping site, it is possible to have a toxic from the chemical content from the rubbish. So it may affect the structure of the building. Okay, so that's why we assume that this footing is exposed to the severe condition due to this kinds of situation. Therefore, a larger nominal cover to the reinforcement is required. Why it is required? Because we need to protect the reinforcement from failure or reduce its strength and reduce its performance that can cause fail to the main structure or superstructure. Despite the value suggested in Table 4.1 in Eurocode 2, established practice in the United Kingdom recommended that the minimum cover should be at least 75 millimeter if the concrete cast against the ground. So means that the footing or the pile cap is directly contacted to the soil, or it not less than 50 millimeter if the concrete is cast against a layer of blinding concrete, where there is a one layer about 25 mm cast as a blinding concrete before we layer down the footing or the pile cap. A concrete class at least should be C30 or 37 is required to meet durability requirement. So it is important for us to understand this. Palcap design, the pile cap must be rigid and capable of transferring the column loads to the pile. Okay, it should have sufficient thickness for anchorage of the column dowel bars and the pile reinforcement, so that it will not tilting up and also have a movement, because we need to make sure that this pile cap is rigid. It must be checked for punching shear, diagonal shear, and bending and also point. Pile are rarely positioned at the exact location shown on the drawing. Therefore, this must be allowed for when design the detail of the pile cap. So there is a deviation that we have to allow. That's why in the pile cap design, we will design in terms of group of pile. Either it is a 3 numbers, 6 numbers, 2 numbers, 8 numbers, 7 numbers, or 9 numbers normally as a maximum numbers. So we have to choose, okay, what is the suitable configuration of the pile cap in order for us to group the pile in order to support the load from the above column. Two method of the design is a beam theory. The Palcap is treated as inverted beam and is designed for the usual condition of the bending and shear. We will see on the example. And then another one is a truss analogy approach used to determine the reinforcement requirement where the span to depth ratio should be less than 2 such that the beam theory is no more appropriate. So we will see the difference between this beam theory and also truss analogy theory, which element or which parameter that cause the difference and what will be the result. Okay. On the Palcap dimension, okay, here are the example of the Palcap dimension that we have to know based on the suggestion of the Palcap group. So if we have a 2 numbers, 6 numbers, 5 numbers, 7 numbers, 4 numbers, and also 9 numbers. Okay, here are the dimension of the pile group if we have a 2 pile. So, K, for example, if we have a 2 numbers of pile per pile cap, here are the dimension of this H and also B, which is K plus 1 time with pile diameter plus 300, and then the distance or the span between each pile, okay, or spacing is K time with the pile diameter. K normally we use a 3, so it's depend on the condition of the site. So it's depend on the soil condition. Commonly, it is used as a guide to determine the Palcap dimension. Okay. So, on the truss analogy theory, here are the assumptions. The force from the support column is to be transmitted by a triangular truss action with concrete providing the compressive members of the truss and steel reinforcement providing the tensile tie force. Upper nodes of the truss is located at the center of the loaded area and the lower nodes at the intersection of the tensile reinforcement with the center line of the pile. So here are the figures shows how it's look like. Okay, so means that here are the load. Okay, here are the uh, pile. Okay, so we're using a truss theory here, which is the triangular. Okay, so if for example, in this case, we only have a 2 numbers of pile. So if we have 4 numbers, we will have a 2 truss. So means that we have to times 2 in terms of the area. So we will have a look on the example later. Okay, on the truss analogy method, when the pile space at a distance greater than 3 times the pile diameter, which is K is more than 3, only the reinforcement within a distance of 1.5 times the pile diameter from the center of the pile should be considered as effective in providing the tensile resistance within the truss. So this figure showing that, okay, the how it's look like. Okay, so this is the pile. The required main tension reinforcement should be, okay, at the distance 1.5 time with the diameter. Okay, at least 1.5 diameter. Okay. On the truss analogy theory, here are the things that I said. So taking example of 2 pile cap, the force diagram is shown in this figure below. So here is only for 2 pile cap. Therefore, the geometry of the force diagram T is equal to NL over 2D. Okay, L is the distance between, okay, of distance between the pile. Hence, the required reinforcement area is A as required, P over FYD. T is equal to N times L. Okay, and then FYD is equal to 0.87 FYK. Okay, 2D because of 2 numbers of the reinforcement. So if it is a truss analogy theory, because we're using a if it is a 4 pile group as shown, the load can be considered to be transmitted equally by parallel pair of truss. So means that we divided into 2 sections of the truss. So the first one and then the second one. Therefore, the T is equal to T over 2 because we are going to have it half. Okay. So for one truss only. Okay, the reinforcement should be provided in both direction. And then this is the formula for the tensile force, okay, for the 2 numbers, 3 numbers, and also 4 numbers. Okay, so designed for the shear, okay, shear capacity of a pile cap should be checked at the critical section taken to be 20% of pile diameter inside the face of the pile. Shear enhancement may be considered such that the shear force VED may be decreased by AV over 2D, where the spacing of the pile is less or equal to 3 times with the pile diameter. This enhancement may be applied across the whole of the critical section. Otherwise, it may only be applied to strip of width 3 times of the pile diameter located central to the each pile. So means that, okay, so this is the location of the punching shear parameter. So the distance, okay, between this punching shear parameter to the uh, to this section is about diameter of the pile divided by 5. Here, distance from the column face to this shear section is called as a AV. And then punching shear and the maximum shear check. So if the spacing of the pile is more than 3 times diameter pile, the pile cap should be checked for the punching shear. The critical parameter for punching shear is at the distance 2D away from the column face as shown, same as what we have done before. The shear force at the column face should be checked to ensure that it less than 0.5 V1. FCD U is the column parameter, equal to 0.5 V1 FCK over 1.5 UD, where U is the parameter of the column, as I said, and the strength reduction V1 is equal to 0.6 times with 1 minus FCK over 250. So here are the section, okay, same as what we have done before. Okay, seldom critical for the pile cap unless the pile spacing is exceed 3 times with the diameter of the pile. Sizing of the pile cap. So this is normally assumption of the pile cap sizing. So this one is for the span pile, okay, for the diameter. So we should know what is the cap depth at least, okay, which is the small h. So even 100, if it is 300, okay, 400. So this is just an assumption. So if you would like to adjust it into smaller size because of the budget, and then to control the cost of the project, it can be it. This is just a suggestion. So we have to carry out the crack control in order for us to make sure that the spacing between the reinforcement is able to sit within the maximum and also minimum area of the required, and also between the maximum between the allowable spacing of the reinforcement, so that it will not cause a crack check. On the detailing, okay, what we have to know on the detailing is, as usual, we have to check the AS minimum and AS maximum. So for the reinforcement, AS maximum is 0.04 AC and AS minimum is equal to 0.26 FCTM BD FYK and 0.013 BD. So another thing is same what we have done before. So we should provide an additional reinforcement in order for us to make sure that at the top and the bottom face, in order for us to tight up the reinforcement, because it's quite that about 650, for example, 700 millimeter for the thickness of the parquet. So the minimum allowable reinforcement spacing, as usual, we have to follow the aggregate size plus minus 5 mm. So you can take as a 25 millimeter. So next, this is the detailing. It's normal to provide fully lapped horizontal link of the size not less than 12 millimeter. So it's normal when we would like to provide the minimum size of the diameter bar is 12 millimeter, and the spacing not greater than 250. So means that it should be, okay, for the lapping, maximum is 250 millimeter, so that we will not cause a failure to the structure. The pile should be cut off so that they do not extend into the pile cap beyond the lower mat of the reinforcing bar. So we have to do a cut off point of the pile, okay? Otherwise, the punching shear strength may be reduced. Normally, the protrusion of the pile into the pile cap is approximately 75 millimeter for the precast file. So means that okay, at least it penetrate in 75 millimeter into the pile cap. So this is the cut off point. Starter bar for the pile should be extended into the pile cap with the sufficient anchorage length in order for us to transmit the load from the column to the pile. Dowel bar of the column should rest on the bottom face mat of the pile cap with enough anchorage length embedded in the pile cap. So I will give an example later in designing the pile cap using a truss theory and also a beam theory. So I hope that by this introduction you have a very big view on how to design the pile cap and what is important in doing the pile cap design. So if you have any question, you may come and see me or ask me or contact me through any medium. That's it for today. Thank you. Assalamualaikum warahmatullahi wabarakatuh.